All right, guys, here is your first pre-calculus lesson. Like I told you in class, we are going to go fairly fast through chapter 1 so that the rest of the school year we can slow down the pace a little bit. This should all be review, but if it's not, feel free to reach out and ask any questions that you may have about this. All right. So we're going to do 1-1 and 1-2 today. All right, so first thing, talking about a relation. A relation is a set of ordered pairs. Okay. The domain is the first set of numbers or the x values. And the range is the second set of numbers or the y values. So I'll just give you a quick example. So I'll say x1, y1, x2, y2, x3, y3. Okay. So that's a relation right there. Also, I hope you enjoy my colors. Okay, so the domain is going to be the first number, and your range is going to be the second number. Okay. All right. So here is an example. We have unseated clouds and seated clouds, something to do with the some question in the book. So our relation is going to be these written as an ordered pair. Usually you'll see one of these lovely little curly brackets. Okay. So we are just, I could even write it over here. We're just going to make this column the x's, this column the y's, and write these all as ordered pairs. Okay, so I'm just going down my list of my pairs. I'll use the next line. Just because I don't want to cram it in there. So you can see what I'm writing. And we're going to end it with a curly bracket. So that's going to be a relation. Okay? So the next question is going to say, what is the domain and range of our relation? All right. So this is going to be a list. So we'll go list, curly bracket. So this is going to be, the domain is just our x values. Right here, domain is the x values. So we're just going to write all the x values. Okay, I'll underline them in blue, the same domain color. So domain is this blue. So all those x values, we're just going to make a list of them. There's your domain. Okay. My range is going to be all of the y numbers, which is just the second number. Okay. Here's my range. Same thing. Just write a list of them. All right, so that is writing a relation and domain and range. Okay, next part. Example, write the relation as a table, then graph. The domain is all positive integers less than 6 for y equals 3 minus x. All right, so we're going to make a table. We have an equation, so we're going to probably have x and y values. Okay. It tells us all positive integers less than 6. So if we know it's positive, we know that it has to be starting with 1. We know that they're integers, so we're going to count by whole numbers. 1, 2, 3, 4, 5, less than 6. So I'll underline positive integers, less than 6. Okay, so I'm just getting my x values, then we'll use those to find our y's. Okay, we can't go to 6, so 5 is our biggest one. So now we're going to plug these numbers all into here to get our y values. All right, so quickly we'll just do 3 minus 1. That is 2. Put a 2 in there. 3 minus 2 is 1. 3 minus 3 is 0. 3 minus 4 is -1. Okay. So we need to write the relation as a table, then graph it. All right, so there's my table. So now I'm going to make a graph. Okay, we're just plotting some points here. So I'm going to go over 1 up 2, over 2 up 1, 3, 0, 4, -1, 5, -2. Okay. So there is, there's my table as a graph. Okay. Well, can you see it all? Okay, good. Boop, we can. If you have any questions, just jot them down and feel free to contact me and I'm happy to help you out. All right, next example. State the domain and range for each relation. Okay, so my so we're going to take a look at these graphs and we're going to talk about the domain and range of each of them. So we'll talk about the domain of this one and the range. So my domain is all of my x values. So what are possible x values for this? Looks like this goes forever on in the x and this goes forever on in the x. So that means that my domain, we could say that it is all real numbers. We could say that it is negative infinity, to positive infinity. Okay, so it's just two different ways to write it. The range is our y values. Well, this is going to continue forever in the y's and forever down in the y's, so it's going to be the same. All real numbers. Or if we're going to write it in number form, we can say negative infinity to positive infinity. Either of those work. Let me pull this up for you. All right, so let's look at this next graph here. Our V graph, which is also called our absolute value graph. Okay. Our domain is going to be our x's. So this is going to cover x's forever, as will this. So our domain is going to be all real numbers, or negative infinity to positive infinity. And then my range. Okay, let's look at our range, our y values. Well, it looks like we don't have any y values until we get to 0. So it looks like our range, and then it goes up forever. So our range is going to be that y is greater than or equal to 0. Okay, so yes, it can be 0 or bigger. I just noticed an error I made that I know one of you would have caught beforehand. Range is the y value, so this right here needs to be a y. Whoops. These notes, unless something crazy happens, I'm going to keep going on. Errors are errors, and I want you to see I'm a human too. So please give me grace like I will be giving you grace this year. Okay, so a function. A function is a relation in which each element of the domain, our x's, is paired with exactly one, super important, element in the range, or the y's. Okay, so another way to say it is a set of ordered pairs in which no pairs have the same first element. So your x's have to be unique. I'll write that for you. X's must be unique. Left my black pen over here. All right. So right down here, state the domain and range. Then if it is a function, then if it's a function. So tell us the domain and range, and then tell us if that's a function. So we'll start here with the domain. Our domain is going to be the first number, so -3, 4, and 2. My range will be the list of second numbers, so 0, -2, -6. Is this one a function? Are all of these first numbers unique? Yes, they are. So yes, that's going to be a function. Okay, let's look at the second one. Domain is the first one, so we got a 4. A 4, when you have a repeated number, we could write it twice for sake of this. 9, -9. When you do make a list, if you have a repeated number, you don't have to write it twice. We could have put these in numerical order also. I just made a list of them, okay? The answers in the book will be in order though. -2, 2, -3, 3. Is this a function? Are all of the x's unique? No, they're not, because 4 goes to 2 different numbers. Goes to -2 and to +2. So the answer is no, it can't be a function because it's not unique. All right, next page. Using the vertical line test, determine if the graph represents a function. So pulling way back, okay, vertical line test. So pretty much if you take a vertical line, put it across your graph, if no points are in the same spot vertically, then it's a function. So vertical line test here, we'll go through. Do any of our dots overlap? No, they don't. So yes, this is a function. Okay, we'll try this one. Whoop, there's lots of dots that overlap. So like here and here. So this one's going to be a no. We'll go here. This one's a no as well because these shaded areas mean all this is included. So anything down here overlaps. Okay, and then our last curve, nothing overlaps. So yes, that's a function. It is as easy as that, unless it tells you to find the domain and range. It's just a yes and a no. All right. Function notation. Function notation can use any letter. So we could say f of x, gt, ht, okay? This right here is read f of x, or the value of the function f at x. Okay. So in ordered pair form, it would look just like this, x comma y, or x comma f of x. So pretty much what we're saying is our y and our f of x are interchangeable with each other. When we're talking about a function, we use f of x, we could use g of t, just to talk about the x value in terms of that function. All right. So example, evaluate the function for the given value. So we have f of 9 if f of x equals the absolute value of 6x minus 77. So what we're going to do is we are going to put 9 in where x is. So what we're saying is that x equals 9, and we're going to put that into our equation here, our function. So I'm going to say f of 9 equals absolute value of 6 times 9 okay. 6 times 9, 54. 54 minus 77. This is not, I have this written down. I'm not doing this miraculously in my head. So then absolute value, get rid of that negative. So the answer is 23. So that would be your answer. Okay. All right, so in here, we are going to say that h of c minus 5 if h of x is equal to this equation. So what we're saying is that x is going to be equal to c minus 5. So everywhere that there's an x, we're going to replace it with a c minus 5. Okay. So h of c minus 5 equals, okay, here's one, c minus 5 squared. Here's another one. All right, so now we're going to do some mathing it out, okay? And hopefully we won't run out of space. Okay, I'm going to undo this. And right here, for sake of time and space, I'm just going to FOIL this 7 out. So I'm going to have 7c. Remember, this minus has to go with that 7. So we have a negative times negative, so it's going to be a positive 35. Okay. So now FOILing this out, I'm going to have c squared minus 5c. Now move over. Minus 5c plus 25. I'm going to bring everything down. Okay. One thing that I know happens is that we get lazy. And lazy math is when you accidentally get a wrong answer. Okay? That's why I like to write it all out just so I can see it. I'm going to combine some like terms here. So I'm going to grab my lovely pen so I know where all of my C's are. And I'll grab another one. We'll use the yellow. Hopefully you can kind of see it. Barely. Okay. All right. So I have minus 5, so 10. So minus 17c. Okay. And then 25 plus 35 is 64. So that is my answer. Is it okay that my answer isn't just a number? Yep, because I had a C in there, so it's not going to come out to being just a number. All right. When the domain is not specified, the domain is all real numbers, for which the corresponding values in the range are also real numbers. Okay. On some of these problems, it's going to ask you to find what the domain is and tell us. Like this problem says right here. State the domain of each function. Okay. So how we do that is that we need to make sure that the y values are all are a real number, and then that will tell us where the domain can be. Okay, let me show you. So for example, bottom of a fraction, when is that not going to be a real number? When this is equal to 0. Okay. So what we're going to do is we're going to find out when this equals 0. So we're going to have to pull out an x. I know we're pulling out some math skills you haven't used all summer. Don't worry, I haven't used them either. Okay, so we have x equals 0. Whoops. X minus 4 equals 0. And x equals 4. Add this to both sides. Okay, there you go. So we know that x cannot equal 0. Okay, why? Because that would make the bottom of this equal to 0, and that is not going to work for our equation. We also know that x cannot equal 4 because that would make it our equation equal to 0 on the bottom and not be a real. So I'm okay if this is your answer. Okay, or you could say all real numbers except where x equals 0 and 4. All right. This one, okay, same thing. Fraction can't be 0. Okay, what about our square roots? They can't be negative. So we know that we need to find out when this is greater than 0, because we can't have it be negative. So we're going to say, when is x minus 4 going to be equal to 0? Okay, when x equals 4, it'll be equal to 0. If, so now I'm going to check. If I put a 4 here, that's 0. If I put a 5 here, that's positive. Good. If I put a 3 here, that's going to be negative. All right. So we are going to have to say that we want x to be greater than 4. Okay. Can it be 4.1? Sure, because then the bottom's going to be the square root of 0.1, and that's okay. At this spot right here, we could have also written x minus 4 has to be greater than 0. And when we solve that inequality, we would have gotten the same answer. Okay, so that's our domain. All right. Operations with functions. These are, oh, I'm stuck. Okay, these are some operations that we can perform with functions. So the first one is our sum operation. So if we have f plus g of x, it's the same as just taking our two functions apart and adding them together. Same with the difference. This one matters in the fact that our order is going to matter with which one's first or second. And remember, this subtraction is going to apply to everything in g of x. Product, we're going to multiply them together. And quotient, here it is. Remember, the bottom of our function cannot be equal to 0. All right, so let's try some out. So given that f of x equals 3x squared minus 4 and g of x equals 4x plus 5, find each function. Okay. So pretty much this is just saying that we're going to do f of x plus g of x. So we're going to take f of x, 3x squared minus 4, and we are going to add it to g of x, which is 4x plus 5. This one's pretty easy with like terms, so there's no other x squareds. There's no other x's. We just have a -4 and a +5, so we're going to get a +1. And that's going to be my answer. Done. Super easy. Okay. All right. This one's going to be equal to f of x minus g of x. So we'll write down f of x, 3x squared minus 4. And then we're going to subtract g of x. This point, really important that all of g of x needs to be subtracted. So maybe put it in a parenthesis. So you remember this minus goes to both pieces. So I have 3x squared minus 4x. And then I have -4 minus 5. So I'll have -9. Done. Answer. Okay. At this point right here, if you wanted to rewrite it as 3x squared minus 4 minus 4x minus 5, that might have been easier. Okay. Totally fine. All right. Next one. Oh, I wrote them on different lines. F of x times g of x. So I'm going to take my f of x, 3x squared minus 4, and I'm going to multiply that whole thing by g of x, 4x plus 5. Okay, so fun foiling ahead of us. Sorry for the wobbling. So 3x squared times 4x will be 12x to the third, because I have 2 there and 1 here. Okay, let's do this one next. 3x squared plus times 5 will be 15x squared minus 16x, and then this goes to the end, minus 20. Okay. There's no like terms to combine, so we are done right here. So maybe a little bit more work to do, but really not. So this one's f of x divided by g of x. So we'll take f of x, 3x squared minus 4, divided by g of x, 4x plus 5. Okay, there's no combining, we can't take anything out. There's no dividing, we can't do anything. The only thing that matters on these ones is that we need to find what my domain can't be. So what's going to matter is this bottom can't be 0. So we're going to do 4x plus 5 equals 0 to find out what okay, so we know that x cannot be -5/4. So this is pretty much our answer. All right, next one. Composition of functions. So we would say f of g of x. So what we're saying, this of is a little bit different here. Okay, this is saying putting the function g of x into the function of f of x. Okay. So let's look at a problem like that. Scoot my stuff up. Okay. So find this and find this. Here's my two equations. So this is the same as saying f of g of x. So what we're saying is that in the f, the x is going to equal whatever g of x is. So we're really saying f of, we're really just putting this in for the x's. So we have f of x equals 2x squared minus 3x plus 8. Okay, so I'm actually going to put this g of x, which is 5x minus 6, into all those locations. Okay, so the hardest part about doing this over video and not being with you guys is when I accidentally make silly math mistakes and no one is yelling at me. All right, so FOIL this out. Okay, I'm going to distribute that now, so I'll have 15x negative 3 times negative 6, so that's going to be a positive 18. Plus I decided to do this rogue without my calculator, so that adds today to that. So 2 times, so I have 25x squared. 5 times that is minus 30x minus 30x plus 36. Remember, you got to make sure, okay, since these two are just floating out here, I might just combine them. But I was going to say, make sure you're careful with your order of operations. Oh, so that would be 26. I'm going to distribute this 2, so 50x squared. If I combine those, that'll be minus 60 times that, so negative 120x. Plus 36 times 2, 72. All right, like terms now. There's no other x squareds. So I got negative 135x plus 98. Whew! That's what the answer says it is. So there we go. We made it. I'm okay if you use a calculator. You don't need to use your head. It's okay. Okay, so this one is g of f of x, which means that we are putting f of x, we're making x equal to f of x. Okay, so we're going to put that into it. So we'll write down g of x so we know what we're working with. And we're going to put 2x squared minus 3x plus 8 into that. Okay. All of this writing down I'm doing is so, yes, you can see it, but also so I don't lose something. Okay. All right, so we're going to distribute here. Then we just need to combine that ending piece. So we got 10x squared minus 15x plus 40 minus 6 will be 34. And we're done. Okay. The hardest part of these is figuring out what goes into what to get your answer. Because there is no fraction or anything, we don't have to find a domain. A note for you though, the domain of a composed function, so these are composed functions, is determined by the domains of both f of x and g of x. So if one of these happened to be a fraction, then that would impact that. All right, last page. Okay. State the domain of f of g of x for these two. Okay, so your domain is impacted by whatever the domain of both of these is going to be. Okay, So we're going to find the domain of this. So this is going to be, we need to find out when, we need to find out when these aren't going to work. And then we have to find what f of g of x is going to be. Okay. So we'll start with f of g of x. Okay. Our x is going to be equal to 1 over x squared. Okay, so then f of 1 over x squared, square root of 1 over x squared minus 4. Okay, that's our composed function. So, first of all, this can't ever be 0 because of this bottom, right? So x squared equals 0 when x is 0. So we know that x cannot equal 0. Okay. We also need to find out when this is going to be, equal to 0, because we can have a square root that's negative, that's equal to 0, but we can't have one that's negative. Okay. So we're going to do 1 over x squared minus 4 equals 0. We're going to solve to find out, I guess we could say greater than 0. So we got to find out when that's going to be greater than or equal to 0. Whew. I'm going to swap these two. Okay. It's the same as multiplying by 1/4, multiplying by x squared. You just swap the top and the bottom. Square root both sides. When I square root, I need to plus or minus. Okay. So that means that x has to be okay, when I minus this, I gotta flip that sign. So, okay, here, let me rewrite this. Okay, so I can keep this the same. X has to be less than or equal to 1/2, okay? Then if I make this side a negative though, I gotta flip my sign because of that rule. So what we're gonna say is negative 1/2 less than or equal to x, which has to be less than or equal to 1/2. Okay, but x cannot be 0. So that's my domain. How would I find it? I needed to make sure that these were going to be real. I could have checked this one as well. Let me just throw it down here. We know that x minus 4 is going to have to be greater than or equal to 0. Okay. So that one's not, in the end, this one isn't going to matter because this is what's going to matter. All right. Last thing. For reals. Find the first 3 iterates, x1, x2, x3, of the function this for an initial value of x0 equals 1. So when we're talking about iterates, we are plugging in the answer for the next one. Okay, so I'll show you what I mean. So, what we're going to do is this is x of 0 when x equals 1. So we're just going to plug that in. And we're going to get an answer of 2 minus 3, which equals negative 1. Okay. So now for x1, our answer is going to be a negative 1. And we're going to plug that in. So we're going to have -2 minus 3 equals -5. So then this becomes x1, this becomes x2. So we use it on the next one. So it's pretty much just using your answer from above. That's x3, okay? So using your answer from above for the next answer. It wants us to get x1, x2, x3. Look at that, we got them. So those are our answers. You could write them in a line that these are your first 3 iterates. Either answer works for me. All right. Your homework, it is on Google Classroom. It is also right here. Page 10, number 21 to 51, every third. Make sure you're doing every third, not giving yourself more work. Page 17, number 12 through 27, every third. Okay. The answers are also in Google Classroom. Please be honest and check those. And you can also know how you are doing. And we will talk more next class period. Have a wonderful day.